Welcome, ladies and gentlemen. Today I'm going to be teaching you a lot of ways to find the derivative of many different types of functions. Guess what those four functions are? We're going to be finding the derivative of secant. Yes! We're going to be finding the derivative of tangent. Yes! We're going to be finding the derivative of cosecant. Yes! And we're going to be finding the derivative of cotangent. Alright, let's go. Alright, so we'll go through each one of these just one step at a time. So first we'll learn how to take the derivative of secant. So we'll start out with the function y equals secant 2x. Alright, and then some important things to know. So if you want to take the derivative of this, you have to know that the derivative of secant is secant times tangent. Okay, so to rewrite this, you would have secant 2x times tangent 2x, and then just like the chain rule, you would take the derivative of the inside. So the derivative of 2x is just 2. Okay, and then from there you can write that out differently if you want, and it would be 2 tangent 2x times secant 2x. And that's all you need to do to find the derivative of secant. Alright, so now we're going to find the derivative of cosecant, which is basically the same process as finding the derivative of secant. You just need to use a different type of equation because you're dealing with cosecant rather than secant. So we'll start out with the equation y equals cosecant 3x squared. Alright, and now to find the derivative of this, we'll go ahead and start this out, and we need to know that finding the derivative of cosecant would equal negative cosecant times cotangent. Alright, so if you write that out, it looks like this. So it would be negative cosecant 3x squared times cotangent 3x squared. And then just like we did with the derivative of secant, we would use the power rule to find the derivative of the inside function. So 2 times 3 is 6, and then times x, subtract 1 from the original exponent, 2 minus 1 is 1, so it would just be 6x. Alright, and if you wanted to simplify that out, it would be negative 6x cosecant 3x squared times cotangent 3x squared. And that is how you find the derivative of cosecant. Alright? So now we will move on, and we will find the derivative of tangent. Now, the derivative of tangent, again, just like the other two, we'll start out with the equation y equals tangent x to the fourth. Alright, and to find the derivative of tangent, we have to know that the derivative of tangent equals secant squared. Alright, so if we rewrite that, we would have y equals secant squared x to the fourth, and then we would multiply that times the derivative of the inner function. So the derivative of x to the fourth would be bringing 4 down in front of the x. You get 4x, subtract 1 from the original exponent, which is 4. 4 minus 1 is 3. And that would be the derivative of the inner function 4x cubed. And then if you wanted to simplify that, you would have 4x cubed secant squared x to the fourth. And that is how you find the derivative of tangent. And you'll notice the similarities and differences between all these. And as we go on to the last one, finding the derivative of cotangent, so we'll start out with y equals cotangent 3x. Alright, and if we want to find the derivative of that, it equals negative cosecant squared. So we would have negative cosecant squared times 3x, and then just like we did with the derivative of tangent, you just find the derivative of the inner function. So the derivative of 3x is 3, multiply it by cosecant squared 3x, and that would be the derivative of this function. And if you wanted to simplify it, it would be negative 3 cosecant squared times 3x. And that's how you find the derivative of cotangent. Well kids, I hope you had fun learning how to take the derivative of secant, cosecant, tangent, and cotangent. I hope you'll check out some of the other videos on how to take the derivative of a function. I'm Justus Winn-Howard, and I'll see you next time.